Integration by substitution, also known as change of variable. There's no standard formula to integrate this function, so I'm going to use a substitution based on the 2x plus 5. So I'm going to use u is equal to 2x plus 5, so I need to change all of these components of the original problem from x to u. Okay, so the x, we just rearrange u minus 5 divided by 2, and that gives us x. That's straightforward. And the root 2x plus 5, now 2x plus 5 is u, and the root means to the power of a half, so that one's done. And then the dx, now we need to do some differentiation for this one, so we start off with our substitution, differentiate, so that's u in terms of x, so it's du by dx equal to 2. This is a fraction, we can take the dx, the denominator, to the other side, so du is equal to 2 dx, and then if we multiply each side by a half, so a half du is equal to dx, so we're going to replace the dx there with a half du. So each of these components is now in terms of u, so we have successfully changed the variable from x to u. Now if we put all of this together, we get this, simplifying, and then expand the brackets, and we have a problem now that we can easily integrate, unlike the original one. So these are just terms with powers on them, so to integrate we increase the power by 1, we divide by the new power, like so. So the integration is now done. The original problem was in terms of x, so we can undo the substitution right now, but it's usually better to do all of your factorizing and simplifying first, and then right at the end undo the substitution. So for factorization, we can take out a u to the power of 3 over 2 from both of these terms, so we have this, and then if we look for a common denominator and combine these two fractions into a single fraction, and the 15 we can take out and multiply with the 4. Now we undo the substitution. Now simplify all of these terms. These are both multiples of 4, so we can factorize further by taking 4 out. So we get 4 over 60, which we can simplify to 1 over 15. That's everything done. Add on the constant of integration. Now this is not the only substitution that works, so here's an alternative method. So we're going to use u squared is equal to 2x plus 5 for the substitution this time. So now x will be u squared minus 5, and then we divide by 2, and if we square root both sides here, we get u is equal to 2x plus 5, and then the square root of that. So this is u, and now the dx, we start off with u squared is equal to 2x plus 5, and we need to differentiate all of these terms with respect to x. Okay, so we're just differentiating this. Now the right hand side is straightforward. Differentiate with respect to x, 2x, we get 2. Differentiate a constant, we get nothing. But we're differentiating with respect to x, u squared. So that's u, that's x, they're different. We have implicit differentiation here. So the u squared will give 2u when we differentiate it, but we need to multiply by du by dx. So now we cancel the 2's on each side. So we have u du by dx is equal to 1. Take the dx to the other side, multiply it with 1. So u du is equal to dx. So we're going to replace that dx with u du. So we now have everything in terms of u. That's u squared. And then we're multiplying this u squared with that u squared and with this minus 5. And now I've done the integration, and these are easy terms to integrate. Single fraction with a common denominator, so that's just multiplying these two and cross multiplying. Factorizing, I've taken a u to the power of 3 out from both of these two there. From the numerator, these are both multiples of 2, I've taken that out, and I've taken the 60 out from the denominator. And now I want to undo the substitution. So this term is straightforward. I'll replace it with 2x plus 5, but I need to work out what u cubed is equal to. So I'm going to square root both sides to get u, then I'm going to cube both sides to get u cubed. So square rooting, and then cubing both sides, and then substituting in. And we can simplify all of these terms. These are both multiples of 2. We take the 2 out, we put it here, 2 over 30 simplifies to 1/15th, and add on the constant of integration, and we have the exact same result as before. So this just demonstrates that when you're using integration by substitution, there can be more than one substitution that will work.